Thank you, Katerina. Hello, everybody. Now I will read, but I'm gonna enunciate and inject emotion into it so it sounds like it's spontaneous. The name of my talk, the long name, I guess, is Artemis, Gaia, aka Gaia, and Orion, queerer than we can suppose, which is a quote from J.B.S. Haldane, the guy who invented neo-Darwinism on the back of an envelope, and who is famous as being the main person in the West, as Alexander Oparin was in the Soviet Union for theorizing on the origins of life from inanimate chemistry and many other things too, some of which will be mentioned. And then after the colon from his a quote, queer than we can suppose, which comes from the line, the universe is not only queerer than we suppose, I suspect it's queerer than we can suppose. In the after the colon is mythology, philosophy, science, and the future, very general. Okay, so I'll begin. As I understand it, she, Artemis, was doubly pissed off. Not only had she successfully lobbied her father, Zeus, into giving her a deliciously edible enchanted forest with deer and rabbits to spare, yellow narcissus flowers, and a tasty variety of edible plants, so that she need never go hungry or have to marry and could remain a virgin forever, even as she was the goddess of childbirth. But when she set sights on the friend of her twin brother Apollo, when she saw the flashing flesh of Orion emerge from the Aegean waves onto the island of Delos, he could walk on water as well as swim. She became smitten. What happened next wasn't exactly clear, but what didn't happen was Orion neglected to mention to her his nuptial status, that he was engaged to, or at least carrying on with, Eos, the goddess of dawn, cursed by Aphrodite with an insatiable lust for mortal men. To make matters worse, at least in the way I would like to tell it, Orion, the hunter, with his glittering belt, began shooting her deer incontinently for sport rather than meat. She was protected on her island not only from marriage, but by the seven nymphs her father gave her, whom Orion also pursued. She was herself a great huntress and archer, carrying a bow and arrow of pure silver gifted her by the Cyclops, as well as hounds provided by Pan to help her hunt. Of course, there are many versions in myths outside of time, but in mine, Artemis, the daughter of the goddess of music, Leto, doubly angry at handsome Orion, alas, a mere mortal, petitions her grandmother, Gaia, to kill him. In my version, Gaia, mother of Earth, with sky god Uranos and of the Titans, sends a scorpion to devour Orion in his satisfied slumber. As the arachnid, with its 8 legs, grasping pincers and upturned segmented tail, with a deadly stinger walked across the forest floor, it increased in size. Orion, fitfully sleeping with the dream of a scorpion, woke up to the horror of its reality and was stung and torn limb from limb. Alas, a mortal, he died. But in my version too, there is an epilogue, a mortal, one emblazoned sempiternally in the lights of the night sky, in the constellations Orion and Scorpio, so that we will never forget what is ultimately an ecological lesson. Do not overhunt. Do not destroy a sacred forest. Sure, Artemis hunted. That is how she fed herself. But she did not hunt for sport, for the transgressive pleasure of sticking it in, or to revel in the power of killing for its own sake. Power makes stupid, wrote Nietzsche. Now, to skip ahead to anticipate a bit, there is a kind of romantic irony, or not so romantic irony, to my retrofitted ancient but modern Greek morality tale. Perhaps the most prominent asterism visible in the Northern Hemisphere from the late autumn to early spring, it goes away in May. The constellation Orion could, should, and would serve as the greatest imaginable reminder beyond the budget of any possible advertising campaign of the dangers of overhunting, hypergrowth, excess resource extraction, depleting local environments of the resources upon which the living beings, including the extractors and hunters who feel most powerful, depend. The message, such as it is emblazoned on a most huge, if remote, canvas, the great night written in starlight. How could we miss it or even forget about the message, even and especially in the heat of the summer when the constellation is no longer visible in the northern hemisphere? There are three stars or star-like objects in the asterism of Orion's belt, together which form an almost magical spell. Alnilam, Alnitak, and Mintaka. Alnilam, also known as Epsilon Orionis, is a blue-white supergiant over 1,000 light years away. It is 375,000 times more luminous than our sun. Alnitak is not, in fact, a single star at all. It is a triple or quadruple star system with a blue supergiant some 33 times as massive and over 20,000 times brighter than our sun, with 20 times the diameter at the center, and a blue subgiant orbiting it every 1,500 or so Earth years. And Mintaka is also a two-star system. Its two stars together some 90,000 times more luminous than our sun. Now, I have a somewhat peculiar or unfamiliar to many view of life as a material phenomenon, one which overlaps with that of Thomas Nail. It is what I would characterize as the fourth in a series of Copernican level scientific deconstructions. The first was that of Copernicus, preached by Giordano Bruno, who was burnt at the stake in Rome in 1600 for suggesting there were an infinite number of inhabited planets, some where man hadn't fallen, etc. Galileo, who discovered what would turn out to be the moons revolving around Jupiter, also believed that Earth moved and was not the unique center of the universe, a belief for which he was confined to house arrest. A second Copernican-style deconstruction was the 1828 discovery by German chemist Friedrich Wöhler that urea, a nitrogen-containing compound found in urine, could be synthesized in the laboratory. This suggested that not only was Earth not at the unique center of the universe, but that life, rather than being special or enchanted, was a chemical phenomenon. A third Copernican level deconstruction was the careful elucidation by Charles Darwin that the process by which life changed was not the result of special creation or divine intervention, but via evolution by natural selection. Today, if chemists showed the elements and compounds of life to be found in non-living forms on Earth, and astrophysicists detected not only organic compounds such as methane produced by termites and formic acid found in ants in space, indeed, all five nucleobases, the structural components of DNA and RNA, have now been found in meteorites and samples from asteroids, suggesting that the essential components for life may have originated from space. If we are not special in place or substance, neither are we in process. All these Copernican level revolutions show that we are part of an energetic, creative cosmos rather than exceptions to it. After organic chemistry and Darwinian evolution, we come to a fourth Copernican style of deconstruction that neither life in general nor we as part of it are special as we thought. That this may be a blow to our ego and the grandiose narratives of simple religions, but with great intellectual excitement, it connects us to the general ferment of the cosmos. The British-born Indian Haldane 1892 to 64, a professed polyamorous Marxist socialist, Mackenzie Wark called him a monster in the 217 keynote of the SLSA in Tempe, Arizona, was a prodigy. My mother, Lynn Margulis, called him beyond brilliant. Haldane learned to read at 3. After injuring his forehead at 4, he questioned his doctor about the fresh blood. Is this oxyhemoglobin or carboxyhemoglobin? James James Watson, famous for helping work out the chemical structure of DNA, called him, quote, England's most clever and eccentric biologist. Francis Crick, who was apparently on low-dose LSD at a British pub when the chemical structure of DNA came to him, as well as Rosalind Franklin, who probably also should have shared the Nobel Prize for her work on the crystallography of life's master molecule, were also involved. Well, it is from the epilogue of Haldane's 1927 book, Possible Worlds, that Haldane's famous statement that he, quote, suspects that the, quote, world is not only queerer than we suppose, but queerer than we can suppose comes. Well, there is a Socratic resonance. Haldane marks his intelligence not so much by what he professes to know, but what he and us all don't know. Born in the gay 90s, the 1890s, and witnessing the cultural fervor and economic boom of the late 1920s, and mindful of the extraordinarily long times preceding the present, Haldane reckons the times from small mammal to man at 40 million years, the most imposing period from fish to man at 400 million years. Haldane, inspired by biology as well as astronomy, takes his cue from evolution to imagine humankind's deep future. Not too deep, mind you. He begs off at imagining humankind's expansion and evolution at 400 million years. That would be too much, even for him. But at 35, in 1927, he's ready to report a long-term projected path of inner solar system colonization and future human evolution, even if it starts with a debacle of death on the dark side of the moon. Ironically, considering the relatively very fast pace at which the moon was landed upon in actual history, Haldane's projected history imagines a future in which tidal forces are exploited for energy. And the first voyages of humans to the moon, rather than occurring just decades after the brilliant Haldane had imagined, had to wait not just thousands, but millions of years to get to the moon, only then discovering features of the far side via personal reconnaissance. Quote, by the year 8 million, the length of the day had doubled, the moon's distance had increased by 20%, and the month was a third longer than it had been when first measured. It was realized that the Earth's rotation would now diminish rapidly, and a few began to look ahead and to suggest the colonization of other planets. The older expeditions had all been failures. The projectiles sent out from the Earth had mostly been destroyed by air friction or by meteorites in interstellar space, and those which had reached the moon intact had generally been smashed by their impact on landing. Two expeditions had landed there with oxygen supply, successfully mapped the face of it, which it turned away from the Earth and signaled their results back. But return was impossible, and their members had died on the moon. Haldane, near the end of his 1927 essay collection, introduces a panoramic apocalyptic parable, ultimately narrated by our far future human descendants, who, though they may not have looked like much like us, had managed to colonize Venus. After 39 million years, the humans had voided their home planet due to a major lunar exigency. Haldane begins humankind's future history with the origin of the planets, including Earth, from pieces drawn out of it from a tidal wave of the sun after an ancient brush. He suggests 1.98 billion years ago with a giant star. This theory of the planets coming from a pass by of another star by the sun was popular in earlier astronomy. Quote, 1,874 million years ago, the sun passed very close to the giant star 3.184.47195543. The tidal wave raised by it and our sun broke into an incandescent spray. The drops of this spray formed the planets, all of which the Earth rotated by far of all of which the Earth rotated by far the most rapidly. The Earth's year was then only very slightly shorter than now, but there were 1,800 days in it, each lasting only a fifth of the time taken by a day when men appeared on Earth. The liquid Earth spun round for a few years as a spherical spheroid greatly expanded at the equator and flattened at the poles by its excessive rotation. Then the tidal waves raised in it by the sun became larger and larger. Finally, the crest of one of these waves flew off as the moon. At first, the moon was very close to Earth, and the month was only a little longer than a day. Although the once favored tidal hypothesis of the solar system's formation was still popular in the 1950s, my future father, a 15-year-old high school student, in Rahway, New Jersey at the time, adopting a tone of scientific authority, railed against it in pencil in a school book. The moon and tidal forces loom large in Haldane's sweeping 1927 cosmogony and future human history. It takes millions of years for humans to get there, and they do so not out of Cold War competition or mere curiosity, but as part of the threat imposed by the moon's decaying orbit. Quote, the moon now began once more to move relative to the Earth, but in the opposite direction, rising in the west and setting in the east, very gradually at first, but then with ever increasing speed, it began to approach the Earth again and appear larger. By the year 25 million, it had returned to the distance at which it was when man first evolved, and it was realized that its end and possibly the Earth's were only a few million years ahead. But the human race on Earth was never greatly influenced by an envisaged future. After physiology was discovered, primitive men long continued to eat and drink substances which they knew would shorten and spoil their lives. Mineral fuels were also oxidized without much forethought. The less pigmented of the primitive races exhausted the fuel under the continents on which they lived with such speed that for some centuries the planet was dominated by the yellow variety resident in eastern Asia, where mining had developed more slowly until they too had exhausted their fuel resources. The unpigmented men appeared to have foreseen this event, but did little or nothing to prevent it, even when it was clearly only a few generations ahead. Apparently, the unpigmented British, after using ships and trains to colonize much of the world and then running out of fuel, did not provide a clear enough lesson to others running out of fuel. Haldane's dates are impressive. It is now 25 million AD, and humans have still not settled the moon or inner planets. Quote, but if most men failed to look ahead, a minority felt otherwise, and expeditions to Venus became commoner. After 284 consecutive failures, a landing was established, and before its members died, they were able to furnish the first really precise reports as to conditions on that planet. In the course of 10,000 years, a race had been evolved capable of life at 1/10 of the oxygen pressure prevalent on Earth, and the body temperature had been raised by 6 degrees. The rise to a still higher temperature, correlated as it was with profound chemical and structural changes in the body, was a much slower process. Projectiles of far larger size were dispatched to Venus. Of 1,734, only 11 made satisfactory landings. The crews of the first two of these ultimately perished. Those of the next 8 were our ancestors. The organisms found on Venus were built of molecules which were mostly mirror images of those found in terrestrial bodies. Except as sources of fat, they were therefore useless for food, and some of them were a serious menace. The third projectile to arrive included bacteria which had been synthesized on Earth to attack L-glucose and certain other components of the organisms on Venus. 10,000 years of laboratory work had gone into their making. With their aid, the previous life on that planet was destroyed, and it became available for the use of man and the 60 terrestrial species which he had brought with him. Escaping the sinking moon, artificially selected remnants of what was once the human component of Earth escaped to survive on Venus. Indeed, it is the Venetians who are narrating humankind's history from the future. Our descendants witnessed the destruction of the home planet from relative safety. Roughly speaking, it only takes them until 35,997,900 AD. Quote, the history of our planet need not be given here. After the immense efforts of the first colonizers, we have settled down as members of a superorganism with no limits to its possible progress. The evolution of the individual has been brought under complete social control, and besides enormously enhanced intellectual powers, we possess 2 new senses. The one enables us to apprehend radiation of wavelengths between 100 and 1200 meters, and thus places every individual at all moments of life, both asleep and awake, under the influence of the voice of the community. It is difficult to see how else we could have achieved us as complete a solidarity as has been possible. We can never close our consciousness to those wavelengths on which we are told of our nature as components of a superorganism or deity, possibly the only one in space-time, and of its past, present, and future. Around the year 36 million, Earth appeared in the sky 25 times the size of the sun. Tidal strain caused massive landslips and earthquakes, and the portion of the moon nearest to Earth, already extensively cracked, began to break up into meteorites a kilometer in diameter, revolving in independent orbits. Watched from Venus, the end, Haldane writes cryptically, came quite suddenly, but the earlier stages were also signified from the Earth. Nonetheless, they were emboldened. Plants, Plans to colonize Jupiter were underway. In preparation, miniature humans were bred by exposing them to the spinning walls of giant centrifuges, selecting them for Jovian gravity to make them small and resistant to forces that would make even a slim 119-pound human weigh 300 pounds. Haldane's last men, Earth-escaped humans who had survived the destruction of the moon, were turning their attention to lightweight, genetically engineered human offshoots bred on Venus to withstand Jupiter's higher gravity. They would be bred in the artificially high gravity of centrifuges, colonization projected, however, probably indefinitely into the future. Well, what does all this have to do, you might ask, with what I've called the fourth Copernican deconstruction? Well, quite clearly, in our desires and those of our empires, if not always in fact, we and life in general show a tendency to grow, to reproduce, to expand. Philosophically, we must defer to Nietzsche, who emphasized in his late notebooks not so much the dictum of his teacher Schopenhauer, the will to life, as the broader category, the will to power. In its metabolism, life, like other non-equilibrium thermodynamic systems, actively seeks and devours energy gradients, reproducing and expanding. However, and this is crucial, because it needs specific chemicals to complete ecosystem cycles, growing or expanding too fast can imperil, first of all, individual populations and species, and ultimately whole ecosystems, including the planetary ecosystem known as Gaia, whose final entropic waste is not shit, piss, or gas, but heat, which it dissipates into space, primarily perhaps by evapotranspiration from trees. There's a starman waiting in the sky, sings David Bowie. He'd like to come and meet us, but he thinks he'd blow our minds. Both the biologist E.O. Wilson and the world's best-selling science fiction author, the Polish writer Stanislaw Lem, converged on an answer to the famous Fermi paradox coined by thermodynamicist and quote-unquote architect of the nuclear age, the Italian and American physicist Enrico Fermi. If there were any other intelligent beings out there in space, where are they? The answer of both were deeply informed by biology. Extraterrestrials have not visited us because they are not expansionist. They are not in an exponential growth phase. Such beings, unlike us, will have already grown up, as Wilson put it, or what amounts to the same thing, they will have settled down. On Earth, after volcanoes, meteors, or even nuclear bombs destroy, life comes back. Microbial and fungal spores settle, seeds come in, members of fast-growing settler species spread, providing food for follow-on species in a process ecologists call succession. So too in our own bodies, the very rapid growth of the fertilized egg from a single sexually merged cell to a body with trillions of cells organized into tissues abates. While we continue to grow relatively quickly after being born, growth slows at adolescence, and the rest of our lives are marked more by physiological maintenance and stability than unsustainable continued expansion. These are verities of the life process. The abatement of initial fast growth may thus apply at the planetary ecological as well as the ecosystem and individual animal level. In the Lem-Wilson answer to the Fermi paradox, we haven't seen the aliens because they are not or are no longer on an interplanetary tear colonizing planets willy-nilly. Without having to understand ancient Greek or to accept anything on the faith of earthlings, they have in essence obeyed the ancient commandments said to have been ascribed inscribed at the Temple of Apollo at the base of Mount Parnassus in ancient Greece. Nothing in excess. Pope Pius the 12th, 1876 to 1958, From him to neo-Darwinist analytic philosopher Daniel Dennett, 1942 to 2024, both maintain that life contravenes, violates the second law of thermodynamics. But despite their very different belief systems, both were wrong. Both relied on the notion that entropy is a synonym for organization, for lack of organization or disorder, as well as consensus confusion of what the second law of thermodynamics says. Far from breaking the second law of thermodynamics, however, organized living systems are arguably one of its most impressive instantiations. One of the most impressive, quote unquote, short-lived dissipative systems, temporary gradient reducing structures, sometimes called chemical clocks, is the Belousov-Zhabotinsky or BZ reaction. It undergoes a striking series of color changes as it produces waves and reduces an electron potential gradient, basically a difference in chemical concentration. The chemical gradient is equalized by the movement of electrons from donor molecules to acceptor molecules. This is an example of a self-reacting chemical reaction, parts of which react over and over again, quote unquote, in order to equalize the gradient. BZ reactions form spiral, target, and stripe patterns. If stirred, a solution of them in a beaker will change in color from reddish to blue to purple to reddish and back to violet in about 45 seconds. Professor Bill Early of the chemistry department of Georgetown, a Jesuit school, likes to tell the story of the time that he was in an elevator returning from a chemistry lecture on such Belousov-Zhabotinsky reactions with the beaker of self-cycling reactants. The elevator stopped at a floor. Two Jesuit priests got in, and the door closed. As the priests gazed, the chemicals changed colors over a scale of several centimeters. Are those alive? Asked one. As much as you are, Father, Professor Early said. These reactions metabolize but don't reproduce. Most of our fellow complexes Most of our fellow complex systems are not necessarily as complex as life, but they show the basic cycling, energy spreading operation without which metabolizing, growing, reproducing, naturally selected life would not exist. Take convection, one form of which appears as hexagonal structures that appear in fluids. Such small convection cells help diminish the difference between the temperature at the top and bottom of the fluids in which they appear. Their temporary existence and geometrical design rectifies a difference, a gradient, and they disappear once their naturally purposeful energy spreading job is done. Although extremely simple, these fluid patterns illustrate one of the most basic principles of naturally cycling complex systems, organizations to enhance the rate of degradation of gradients. In 1897, Henri Bénard, a student in the University of Paris, heard about these structures that would one day bear his name. They were seen to form on the underside of photographic developing trays. Investigating, Bénard set up an experiment. He heated sperm whale oil with 100 degrees centigrade steam in a brass apparatus. With the oil heated from below and the top open to cooler air, he created an 80-degree centigrade thermal gradient across a 1 millimeter layer of whale oil. This was a steep gradient equivalent to an 800-degree centigrade gradient across a centimeter. Immediately, honeycombed flow structures, now called Bénard cells, appeared. In 1957, the great Indian-American astrophysicist Subramanian Chandrasekhar, a 1983 Nobel laureate renowned for his work on the evolution of stars, described convection. The simplest example of thermally induced convection arises when a horizontal layer of fluid is heated from below and an adverse temperature gradient is maintained. The adjective adverse is used to qualify the prevailing temperature gradient. Since, on account of thermal expansion, the fluid at the bottom becomes lighter than the fluid at the top, and this is a top-heavy arrangement which is potentially unstable. Under these circumstances, the fluid will try, my italics, to redistribute itself to redress this weakness in its arrangement. This is how thermal convection originates. It represents the efforts, my italics again, of the fluid to restore to itself some degree of stability. This non-living, organized energy spreading process is not nothing. Peter Sloterdijk writes that, quote, in the most propulsive idea outside of the religious domain, the most ingenious and dangerous notion ever conceived by modern Europeans, Portuguese sailors became engaged in a metaphorical and real sense to the prevailing winds. They devoted themselves, first in thoughts, then in actual ships, to the breezes that continually blow out from Europe's western coast to the ocean, a clockwise whirling of air masses that produces in more southern latitudes a relatively constant current from the northeast and elicits in more northern latitudes a continuous, often stormy western current. The European television viewer today sees this structure in their so-called weather report on almost a daily basis from the perspective of satellites, without suspecting that they have the same climatic political secret of globalization before their eyes. In order for the wind to air their sails, the marineros of the 15th century had to plummet into the invisible whirling vortex and expose themselves to its motion, come what may. It was their idea, which gradually became clear, to drift out to sea for as long as it took until, vertiginously far afloat from a tenaciously adhered to western course before the northeastern trade wind, they pushed forward into the western wind zones of the Atlantic, from which the wind's propulsion would allow them to return home again. This bold maneuver, Sloterdijk avers, which was soon so common that hardly anyone noticed it except for captains, received a sonorous name from the Portuguese sailors, Volta do Mar, the seas about face. Well, we can see here the European colonial expansion, that European colonial expansion hitched a ride on an already existing process of global orderly entropy production. Colonial expansion is itself a form of expanding the realm of active entropy production. If the new realms or the old conquerors or both are not destroyed in the process. These trade winds, as well as jet streams and tropical rain belts, are driven by the Hadley cells, a form of atmospheric convection which consists of equator heated air flowing poleward at around 15 kilometers above the Earth's surface, descending into subtropics and then returning in an organized heat dissipating circulation. There is much more that could be said at this point, but I want to make two more quick points. All of us here likely realize that global warming is a serious problem. As the ultimate waste of Gaia, Earth's biosphere, is heat, it won't do to have it too near to the surface. Ecosystems exposed to heat from nuclear runoffs perish. The production of clouds via evapotranspiration from the leaves of trees, although not integrated into global supercomputer models, is a major form of global cooling. Viewed from satellites, rainforests in the summer are as cool as Siberia in the winter. The eco-artists Helen and Newton Harrison have a projection they call Peninsula Europe, a dragon-like topographical map of Europe after most of it is submerged due to sea rise. Like an overheated laptop or a child with a fever, heat too close to the edges of thermodynamic systems will destroy their ability to produce entropy, spread energy. In this age of mass media and apocalyptic worry, consensus science has become a meme, a flag that is waved. But science, as physicist David Bohm has written, is not about consensus. It is about, quote, finding the truth, whether we like it or not. And right now, the consensus view for the global thermodynamic dysfunction of climate change may be wrong. The major cause of global warming may not be CO2, which remains, unlike on our planetary neighbors, whose atmospheres are both over 90% carbon dioxide, about 0.4% of Earth's atmosphere. The residence time of the molecule CO2 is much longer than particulates from pollution. Let me explain. Looking closely at a temperature profile on the front page of the New York Times on January 19, 2017, Bernard Gottschalk noticed a thermal peak coincident with World War II. The Times graph was based on NOAA's 1880 to 2020 global temperature data. The mid-century spike tops out at the height of World War II and then drops to 1949. Then the slower 2-degree, 2 centuries-long rise in temperature resumes. Plotting Gottschalk's fitted curves for 8 NOAA datasets, the physicist J. Marvin Herndon showed relative temperature profiles over time next to proxies for particulate pollution, concluding from a century plus worth of data that there is a steady, except for the steeper bump peaking in 1945, rise of about 2 degrees Celsius over both land and sea. The rise correlates with global industrial growth increase in aviation pollution, global crude oil pollution, and global coal production. The anomalous bigger jump noticed by Gottschalk takes off about 1940, peaking in 1945 before settling back to join the main secular rise. The striking Gottschalk, or G bump, as we may call it, doesn't settle back to join the main curve until the end of the decade. A valid interpretation of this data is that the movement of mass munitions, peaking with nuclear bombs at the end of World War II, is the reason for the steeper rise within the general trend of global warming. This really needs to be better investigated and then addressed. The main sources of particulate pollution, whose residence time in the atmosphere is much less than CO2, are gasoline additives, coal fly ash, forest fires, and chemical spraying. We could have talked about a likely answer to the Fermi paradox, that is the answer to why, if life is so natural and common in the cosmos, we don't see any clear evidence of other life forms and civilizations. I guess I already mentioned this. Both E.O. Wilson and Lamb converge on the same answer. Mature civilizations are not in a fast-growing phase. Indeed, aging, too often attributed to the accumulation of free radicals, is very likely the result of natural selection against suicidally fast population growth. The naturalist William D. Hamilton, Richard Dawkins called him his intellectual hero and the nearest equivalent to Charles Darwin that the late 20th century has to offer, tried to use neo-Darwinism to prove that aging must exist in all organisms. However, it doesn't. There is a great variety in aging. Naked mole rats living socially in low populations in tunnels under the African desert never get cancer, while cancer-prone mice age much more quickly. Some trees live hundreds of years. Turtles and clams and others can live very long, while mayflies hatch and die the same day. Hamilton's neo-Darwinian math-based theory works in theory, but not practice. Indeed, not only is there lots of variation in rates of animal senescence, but some beings like carrion beetles and Turritopsis matricula, the quote-unquote immoral jellyfish, revert to earlier stages of their life cycle when stressed. This would be like a teenager getting in an accident or fight and going through puberty in reverse. Life appears to have evolved cunning ways to avoid the excess production of entropy, too fast growth, which may destroy it. Aging in a precise statistical sense of organisms being more likely to die next year than this year. Lobsters become stronger and more fertile. Clams can live hundreds of years, trees thousands. Even in our own chordate phylum, turtles and sharks show few signs of aging. Some beetles and jellyfish recover their youth, as mentioned. And so again, with the mayflies dying the same day, as was famously carved at the entrance of the Temple of Apollo in Delphi, along with Noti Sautan, know yourself, and Engua Da'ata, make a promise and you'll be in trouble, was Medin Agan, nothing in excess. Indeed, but modern industrial humanity, civilization, a good idea, as Gandhi quipped, ignores this ancient wisdom. This ecological intelligence appears to be not only written on stone, but also in our DNA in the form of flexible aging that works against overpopulation. Too fast growth threatens populations because they can run out of food all at once or be destroyed by predation or infection. Animal populations which grow too fast risk dying altogether and being erased from stably entropy-producing multi-species ecosystems. Take the Rocky Mountain locust, now extinct. But in the 1930s, I think that's actually 1890s, a cloud of them as big as the state of California devoured fields throughout the Midwest United States. A naturally selected unconscious intelligence presumably prevents organisms from destroying all their food, fatally destroying their ecosystems, or polluting themselves to the point of extinction. The last Rocky Mountain locust was found as a single specimen in 1902. They descended on the wheat fields and agricultural fields of the Midwest, and they laid their egg masses. People thought it was some kind of like biblical plague, and then they all died, apparently. The irony here is that our aging bodies may be smarter than our out-of-control technological civilization. The fall off and growth of the embryo also looks like a population that has learned the hard way not to grow too fast. the early exponential growth of the zygote inevitably abates. Indeed, it looks like an evolutionary freeze frame of populations that have evolved to abate maximal entropy production. Today, there are more than twice as many people on the planet as when I was born. I calculated my infant son's growth rate. He doubled his weight in his first 6 weeks. With 8.66 periods of such doubling each year, at the age of 3, he would weigh over 2,000 tons. That's not how ecology works. The fertilized egg only reproduces exponentially for a while. The same is true of ecosystems. They grow fast in the beginning, but once they reach a certain size, they stop growing. With this comment, we can stop. I want to go back to the story of Artemis killing or having Orion killed by the giant scorpion, less for his infidelity than for his overhunting of her sacred hunting grounds on the Isle of Delos. I want to say that we may think of that when we look at the night sky and see the unignorable reminder of the coruscating stars of Orion, the hunter. A final irony being that that poignant constellation may not even be visible due to light pollution. And now, and now, if there's time and interest, a quick epilogue about this talk's title. Nothing in excess. Yes, although it is from excess and natural selection thereof that evolution produces its multifarious, elegant, and cunning forms. Precocious from the start, J.B.S. Haldane, a professed polyamorous Marxist, atheist, socialist, secular humanist of a Scottish clan, perhaps best known as a primary theorizer in the West of the origins of life from inorganic chemistry, and is credited with coming up with basic mathematical ideas of selfish genes and neo-Darwinism on the back of an envelope, was once asked if, from his long immersion in the study of science and nature, he had learned anything about God. Yes, came back the quick reply. He has an inordinate fondness for beetles, by which Haldane was referring to the tremendously large number of different beetle species. Not only queerer than we suppose, but queerer than we can suppose. But suppose we must. Decades after this biting quip, the great Chicago-born American biologist Lynn Margulis, my late mother, and a writing partner, Joel E. Cohen, and as I mentioned, she called him beyond brilliant, co-authored with Cohen a scientific paper on how infections by Wolbachia bacteria, which has intracellular symbionts, can change sex ratios of beetle species and have been found curled up in their sex cells, argued that the vast proliferation of beetle species may have been precipitated by their symbiotic bacterial infections. Not God, then, but bacteria may have been a major, if not the main driver of speciation in the order Coleoptera beetles. Although the idea of radically different organisms merging to make viable new forms seems like something out of Greek mythology, a violation of propriety and would-be species boundaries, it may nonetheless be true. The world may not only be queerer than we suppose, but queerer than we can suppose. Yes, but suppose we must. And as William Blake wrote in 1789, what is now proved was once only imagined. Thank you.
Thanks, Dorian. It's really not like a question, but it's more like two things that made me that I kind of thought of as you were talking. One is this other myth, the myth of Aristicon, who I don't know if you've heard this one. It's my favorite one, which is very similar. It's like he's this king that chops down the sacred tree of life, and then ends up having like hunger that he can't satiate. And so like he has his daughter, he sells his daughter. The only way that he can finish this hunger is by eating himself. And it kind of like made me think also about, I suppose, the question of like cancer. You know, that is also this kind of like this growth that doesn't stop. And I was wondering, I suppose, what that metaphor might be in the way that you're talking, or you did talk about cancer, but it is that kind of when the growth doesn't stop.
Yeah. Well, my mother would say that in cancer is reversion to like undifferentiated mitosis, which comes before meiosis, followed by orderly mitosis, which is the process by which we come into being as, animal embryos, and then, infants and adults. So when you consider that, like, environmental insults tend to propel cancerous growth in extreme conditions, it suggests that there's a lack of regulation, and it's a reversion to an earlier form of more selfish individual growth rather than the arguably, unfortunately, somewhat totalitarian regulatory control of a healthy, animal body.
John. So thank you very much for a very interesting paper. And you use science fiction writing in a way, and you talked at the end the quotation from Blake about imagined as it happened. So I'm interested in what science fiction as opposed to pure fantasy, which is a kind of species of imagination, so usually has a kind of sustainability in evidence, and an extrapolation imaginable, it's an extrapolation that can be imagined. But from where you're going, citing going millions of years into the future, and I'm just wondering at what point, what would you call that as a genre of investigation?
Well, that's Haldane. I mean, I think it's kind of sui generis. He's fantasizing about the future as a scientist in the 1920s, and it's in some ways it sounds like some crazy gothic science fiction fantasy with centrifuges to make people be able to live on Jupiter and are told by our descendants from Venus. So I mean, I don't know if I would even call that either. It does seem to be something slightly different than either science fiction or fantasy, but also containing elements of both.
Right.
It's sort of like future history imagination. It's in the book Probable Worlds, so it's in the epilogue, I think. It's framed as a fantasy, but with scientific facts and sort of maybe an extrapolation for the sake of clarity of some of the problems that were already evident at that time based on theories that were science but are now superseded by further scientific ideas or progress.
Would you yourself have a view as to, let's say it's called probable worlds versus improbable worlds?
It's actually possible worlds.
His is possible.
Possible.
Yeah, possible.
Okay, probably, yes.
Possible.
Things that be different.
Yeah, exactly, that's right. Sorry, yeah, because in terms of at what point is it now science fantasy, not science fiction? And when you're talking about timescales, okay, so he's projecting into but then he talks about a centrifuge, which is
Yeah, well, then he's using the available technology and the theories of the origins of the solar system at the time. But I kind of like it because it's under erasure because of how quaint it is. But at the same time, you see like the same sort of drive to imaginary or not to populate the inner solar system. We see in somebody like Elon Musk today. It's just a different kind of context and scientific reference. Yeah, and so that drive to expand that you see throughout like human civilization and empires, and is arguably one of the key factors in our present ecological malaise, is already present there. He's talking about the underpigmented skin of the people who are like use all the oil in the 1920s. So it seems like it was pretty close to on target.
Well, that's I was just thinking of this is me being like counting bias, but it's like I was thinking about what cannot be possible, and I was thinking about like Kant's Island. Often people don't like the fact that I will stay and survey the island, right? But there is the kind of speculative thought that's like, let's take this boat and let's go out, let's explore. Maybe Kant is like the great ecologist and says, no, let's not go and like colonize everything else, but let's stay here and become as efficient as we can on Earth. But yeah, I'm just thinking about that.
Is it possible or something like it?
Yeah.
Lots of the words people just can't stay put in there.
Yeah, they can't just stay put.
Stay in the that'll be.
Oh, sorry. Well, actually, my question is a question to both of you guys. at the end of the because, Dorian, you talked about life's ways to find ways to, sorry for that, but, to slow down entropy. And Thomas, in your theory of Earth, you talk about how the capitalist machine that we're unfortunately in accelerates entropy, but then the total, if I'm not mistaken, the total sum of the energy produced by the biosphere gets slowed down because and I'm just wondering how those two thoughts speak to each other, because I don't know if there's a disagreement or if there's like something of a complementary use. And yeah, what your thoughts were, Jonathan? The ways that might find ways to slow down, because it seems to me like you're getting at something of a need to actually go with the speed, yeah, of the total second plan.
Yeah, I mean, I know, no, I think that's a good question, and I hope that my view is consistent with what Dorian's saying, because ultimately it kind of came out of like Dorian, which was that at a planetary scale, the question is whether the entropy of the planet is increasing or decreasing with the advent of capitalism. And I think that mainly, capitalism is like maybe one of the really big ones, but by virtue of cutting down half the trees on the planet, that's a pretty big hit to the planet. Whoever's doing it, whatever's causing that. We started with 6 trillion, we're down to 3 trillion. That's half the trees on the planet. And if what the Dorian is saying, and and Eric in the book, Into the Cool, if those calculations are right, then yeah, I think capitalism is slowing down the entropy of the planet. And then the question is like how to increase the entropy of the planet. But like, I think maybe one consistent, but I'm curious to hear what you think, Dorian, is because the creature, life on the planet is, I think there was a quote, I made a note here about entropy. It's like, there's this old idea of entropy, and I'm sure Joel will have a lot to say about it, is that it's disorder. But you were saying like, actually it's not disorder, like entropy, like life increases entropy, it diversifies it, it finds all these gradients to break down. It's out there seeking out gradients to break down and exert and create diversification. And that is, I think, that's like the opposite of what's happening right now. Right, like all of that biodiversity is like decreasing. Not just trees, although that's the big biomass, but all kinds of creatures are being reduced through extinction and so on. In part, largely because of the last 35 years of global capitalism. But like that's one of the reasons why it's all so like, yeah, I think it's consistent that life is increasing entropy, not slowing it down.
But I would have substantial agreement. I think that's what you have to, there's the short termism versus the long termism. So, when you cutting down trees and turning them into like stuff to build houses and then destroying the dissipative abilities of the ecosystem is ultimately going to reduce both your living organization and your effort and your entropy production vis-a-vis that living organization. The rapid growth is a threat to the sustained growth. So that's a toggle. There's a toggle going on. I do think that, like, yeah, you could. In the science fiction imagination, you have a planet that uses all of the energy of the sun and then all of the energy of the solar system and ultimately the galaxy and stuff like that. But in a practical way, the more you grow and the more entropy you produce, you might have short-term maximum entropy reduction that destroys the system itself. That seems to be what's going on. So it's not like an either or thing. Life is producing entropy. Sustainable life is not producing so much entropy that it destroys the system. It's producing entropy as it lives.
I think that's the subtlety that's like kind of, it's hard. Like when people respond to the theory of the earth argument, like people, or if I just say that this is what's going on, their first response is like, yes, but capitalism is increasing entropy. I'm like, yes, but like too much, like too fast, all like too much. And it's like, it's destroying the conditions of, because that's like, you're right, it's not an either or. It's not like, oh, low entropy is good and high entropy is bad, or the other way around. It's about like metastability. and then for our kind of, you know, somewhat selfish perspectives, or maybe not, but like, if we want to survive, we have to think about that metastability where we can
Like think
live.
about like a Rousseau painting with like a jungle full of vibrant, you know, colorful beings versus like a capitalist parody of that with, you know, slaughterhouses and you know, burning embers in the background. I mean, they're both producing a lot of entropy, but one looks like it keep on going, you know.
Yeah.
It's just.
Yeah, like I think it's like a question of metastability. What is it that we want to be metastable? And I think our answer is like us. Is that all right? We want us to be metastable, and if okay, fine, if that's what you want, then here are the parameters of how much entropy you can handle before that gets destroyed.
Talking about science fiction on this genre of that, I don't read Asimov's The Last Question. So this one is like the last question is about universal expansion. It's a very similar time frame, right? And the last question is two drunk technicians, once they've created a super intelligent machine called Multivac, ask the question, is it possible to reverse entropy? The answer is like, there's not enough data here, insufficient data to respond to that question. And it goes through like they exhaust the sun, they exhaust the suns of the universe, they exhaust it goes to the point, and then Multivac asks itself, and then it responds by saying, let there be light. So it's this horrible, like kind of like a theological beginning that like starts it again. But I will get on this question also of like of entropy, and like what I always think was interesting is that like, of course, like I was doing some research into this, loads of research into trying to understand whether photosynthesis increases entropy, because I mean it does, right? There's like Gibbs free energy decreases through photosynthesis, but trees like don't like increase the entropy from the sun, right? They don't like increase nuclear reactions. Like they're not like, so we, for example, can increase entropy quite easily by like killing more atoms, right? And eating that stuff. But like trees don't like increase nuclear fission. So there's a kind of weird like difference with biomass like generally comes from that. There is a slightly different way in which they are I suppose becoming like the same way. They don't like increase that. So I don't know, I always thought that's something that does mark a certain people.
Well, just a thing that I learned from Dorian's book on this exact question of trees, that like organisms take ahead to retain the biomass of their breeding just to reproduce it. And then they also release a bunch. And mostly that, you know, that bunch is, you know, for us humans, it's like 20% or something like that. But for trees, it's like nearly all of it. It's like 98% of that energy that they take in. Very little is meant to just store as biomass as like the material of the tree. Most of it's just transevaporation. So they're just like these huge pumps, which that's why I was emphasizing trees as opposed to all the other things that we've destroyed on the planet. Destroying trees, it's like just because they really increase entropy on the planet. I mean, they really do a lot of work, and you know, we do some too in our limited way, but we're like 0.001% of biomass on the planet, so that's like a little tiny drop in the bucket, except for the fact that now we're extracting all these fossil fuels, you know, like, and destroying all the trees that are doing all the work, and that's really the crux of it.
I remember a speaker like had this debate with Davos, the French mathematician. He was like, if you want to decrease entropy, concrete Amazon.
Yeah.
He was like, you think entropy is the problem? Like,
That's great.
concrete
Okay,
Amazon.
forget
That's what that whole set
I'm gonna
of speaker
follow
did.
up on
Like,
I did have a question, but I've talked too much.
yeah.
Does anybody else have a question? Then I have a short coffee break and we continue to go on with. Oh, right.
So when is the break? It's supposed to start now until 12.
Yeah.
It's a pretty tight. Also, we make okay. I have a question as well. If somebody else does anybody have a question? Okay, just one quick question. We talked about these things last year. It seems that you would distinguish between entropy and the sense in which the science of physics uses the term, and growth in the way you're using it in the abstract. So economic growth, political economic growth, so human production, human creation of entropy and overheat, human mimicking, let's say, of how entropy works. You wouldn't apply entropy on economy, for example. You wouldn't run capitalism or political economy on the principle of entropy in order to somehow sort out the question of climate change.
Well, I mean, I think, was, John von Neumann, suggested to Claude Shannon in Origins of Information Theory, that he used the term entropy for what's not known about the information, because nobody really knew what it meant anyway. So there's a lot of confusion, entropy, if you like, concerning entropy, but I was in close contact with Frank Lambert, who succeeded in changing in the physics textbooks the definition of entropy, and some of the chemistry in the chemistry textbooks and some of the physics textbook, and saying that it's really been when I'm thinking about entropy, I'm not thinking about informational entropy. I'm thinking about energetic entropy, and the simple definition of it is that it's a measure of the spread of energy and concentrated energy to being spread out, and that's what's going on in all of these sort of natural cycling systems, including life. And so I'm leery of any kind of like overly abstract, and also of the confusion that arises between, like, I quoted both the neo-Darwinist Dennett and the Pope saying that life violates the second law of thermodynamics because it counters entropy, because it's organized. No, the organized systems are in bed with the production and the spread of energy. They don't exist without the spread of energy. In fact, that is arguably their physiological purpose, is to find and destroy available energy gradients. And there's a kind of intelligence even before there's life in this tendency of differences, specifically of heat, but also chemical and other things, to find it. So I through Rod Swenson, who used to be like the manager of the punk band, the Plasmatics, he and this guy Turvey, they had a really good example of a log cabin. And a log cabin, imagine a log cabin, it's warm inside, and wherever there's a little like crack in the cabin, the heat will try to escape. It will go through the outlets, it will go through the window jambs, etc. And so I told this story, which Rod Swenson was pissed off about because he thought it was his story. But I told it to outside a play in Vermont, to Roger Payne, who was the guy who discovered that the whales talk to each other over thousands of miles, and on a house insulator. And the house insulator said that it was reminded of this experience he had, because they put powder and they insulate houses, and he saw with this powder an example where there was an outlet and the streamer of air came up the wall halfway across the ceiling, and then, as if it was changing its mind, it turned around and went out in equilibrate. So to me, that suggests that there, even at the proto-living level, there is a kind of unconscious calculation going on to reduce gradients, and that what the living things that we see and are involved in that process, and that's an energetic process. I mean, there's always the energy and information are connected, but to use entropy as like a flag and an abstract noun, I think it can be more obfuscating than clarifying.
Yeah, this was my question. We had these discussions last summer, and we were wondering whether we were on the right track. Yes, I used it in the sense of energetics, and that's why I said physics in the way the sense of physics would use the term, and whether we could apply it as an ontological principle on everything, because Thomas and I were engaging with this idea that maybe, just letting things run, following the principle of entropy, even in this mass industrial economic global production would somehow be more helpful in finding a solution to the climate crisis, which goes in line with Ludwig Hofstadter also, the abundance principle, like perpetuate the principle of abundance, and just produce and create, and things will sort of figure out themselves, following the principle of entropy.
Well, I mean-
but it seems like we are
The
interfering
thing is,
somehow. Yeah.
we're not just entropy producing systems, but we're long above entropy producing systems with memory. And so when we do industrial versions of maximal entry production, that's a far cry from the learning through
Exactly.
natural selection and physiology and metabolism that has a huge, long history and that we still don't fully understand. So I wouldn't say that like maximizing entry production is a good idea.
I know.
Good idea.
No, I know. I was caricaturing the whole
Yeah.
thing because we got stuck last year in the discussion.
Yeah.
And I think that the problem is that we were too philosophically. We were creating an ontology out of this and then applying this ontology on ethics and everything else. And it felt like it didn't work.
Yeah,
So
okay. Well,
I just wanted to discover the bug in our conversation.